Welcome to the Sigma Magic software. In this module, we will be using hypothesis testing methodology to compare two sets of data. The reason we are using hypothesis testing is because we are working with sample data and we want to minimize the occurrence of type 1 and type 2 errors when we make a decision regarding the data. Let's take an example of comparing the delivery time of two companies, D1 and D2. We want to check whether company D1 has a greater delivery time compared to company D2. 2 weeks of data was collected with a minimum sample size of 56 data points. We will use the following hypothesis methodology to solve this problem. The null hypothesis states that there is no difference in the delivery time between the two companies. The alternative hypothesis is based on what we want to prove. That is, the delivery time of company D1 is greater than the delivery time of company D2. Let's use the flowchart to select the right hypothesis test. We know that our primary metric, y, is delivery time, which is continuous, and our x is the company, which is discrete, and we are comparing the mean delivery performance of two companies, hence we pick the two-sample t-test. For this analysis, we assume that the data sets are normal. We next select the default values for alpha at 0.05 and beta at 0.10. Delta, the practical difference, is given as 2. The data for the analysis is given in two columns, D1 and D2. We have enough information now to perform the analysis. To perform this analysis, we need to add the Compare Datasets template to your workbook. You can do this by clicking on Stats and then selecting Compare Datasets. The next step is to specify the options for this analysis. You can do this by clicking on Update Inputs. Specify the data type as continuous, the data format as raw data, the number of sets as 2, the test as 2 sample t, comparison as mean. Null hypothesis is 0 to compare the two sets of data, and the alternative hypothesis as greater than. Select the checkbox to compute the sample size and then specify the delta as 2 hours. Click on OK to save the options and enter the data on the worksheet. Click on Compute Outputs to generate analysis results. The text results are shown in the Notes section. The assumption checks if the data is normal. In our case, it shows that the data is not normal, so ideally we should not be using the two-sample t-test. The sample size check shows that we have sufficient samples to make less than 5% alpha error and 10% beta error. The sample stats show that the mean delivery time for company D1 is 12 hours and for company D2 is 10 hours. The difference in delivery times is around 2 hours. The p-value also shows that the results are statistically significant. The 95% confidence interval shows that the difference is greater than 1.1 hour. The graphs section shows that the p-value is significant and the confidence interval plot does not include the null hypothesis. In summary, we can conclude that there is a difference between the two populations, but the difference may not be greater than 2 hours as desired, and in the worst case may be only around 1.1 hour. If we had to redo the analysis, we would probably pick the Mann-Whitney test since the data is not normal. That's all there is to compute the process capability analysis. Check out the other modules in this series to learn more about the different capabilities of the Sigma Magic software. Thank you for watching.